Alright guys, so today we're going to start off with a couple bell ringers, reviewing some stuff we talked about. So parallel, perpendicular, or neither. If you're determining if lines are parallel or perpendicular, remember you want to look at slope. So if their slopes are the same, they're parallel. If their slopes are inverse reciprocals, right? So what I mean by inverse reciprocal is like 1/2. Positive will become negative, 1/2 becomes 2/1. So these would be perpendicular slopes. Or if none of those happens, then neither. It's just two random intersecting lines. So let's start with slope. Remember your formula for slope is y2 minus y1 over x2 minus x1. Rise over run. So for AB, let's start there. Your slope is y2 minus y1, so 9 minus 5. And then keep the same order. So we did 9 minus 5. We're going to do 4 minus 2. 9 minus 5 is 4. 4 minus 2 is 2. 4 divided by 2 is 2. So there's AB's slope. And then CD, we have 4 minus 3. And keep the same order. So we did 4 minus 3. We're going to do -1 minus 1. So 4 minus 3 is 1. -1 minus 1 more is -2. So we got a -1/2 slope. And it is just a fluke that I wrote those numbers before because I did not know that that was the answer. So if you notice here, negative became positive, 1/2 became 2/1. These are perpendicular. Or you could always use the symbol for perpendicular, that upside down T. All right, next one, DE. So let's look at DE. We'll do our slope. So 6 minus 2, there's my y's. And then keep the same order. So we did 6 minus 2. We're going to do 3 minus -6. 3 minus -6. 6 minus 2 is 4. Minus negative becomes plus, so 3 plus 6 is 9. So we have 4/9. And then EF, we're going to do the same thing. Y, 6 minus 6. X's, 4 minus 3. We have 0 divided by anything, but divided by 1 is 0. So notice these are definitely not the same, so it's not parallel. They're not inverse reciprocal, so it's not perpendicular, so that would be a neither. We just have two random intersecting lines. Two random intersecting lines. So next one, instead of giving us points, they give us actual lines. So it's actually a little bit easier here because I know my slope is 4. I don't have to do much work. So my slope is 4 on this one. Now here, y is not alone. We don't have it in slope-intercept form. So you can't just tell me, don't tell me, oh, your slope is 5. You have to get it into that y equals mx plus b form, like this one was, so that you can pull out the slope. So let's get y alone. We're going to subtract 5x from both sides. So we have 2y, we have a -5x, and a +1. And now we're going to divide both sides by 2. So we have y equals -5/2 x plus 1/2. And your slope for this one would be -5/2. So we have a slope of 4 and a slope of -5/2. So that would be neither or none. Or sorry, intersecting. Guess I should read the answer choices. So parallel would be same slope, so 4 and 4. Intersecting is anything else. Coinciding means it's the same exact line. So yes, it has the same slope, but it's also the same exact line. So this one was y equals 4x minus 3. This one would have had to been y equals 4x minus 3 for coinciding. So we're going to put intersecting. Just two random intersecting lines, nothing special about them. All right, let's move into the lesson for today. We're going to move into classifying triangles. So we've actually already talked about angles, acute angles, obtuse angles. So an acute triangle has 3 acute angles, right? All these angles are less than 90. Equiangular, equal. So equiangular, all the angles are equal. And all the sides are equal, right? It actually winds up going hand in hand here. So if you have 180 degrees and you have 3 angles to split it between, each one's getting 60. And that's a big concept. You got to remember that each angle is 60. So whenever you hear equiangular or equilateral, you know every angle is 60 degrees. All right, right triangle, you have 1 right angle. And you can only have 1 right angle. And then obtuse, you have 1 obtuse angle and only 1 obtuse angle. The other 2 are going to be acute because you only have 180 degrees to divvy up. All right, so that's classifying by angles. So let's look in the picture. The first one wants us to classify by angles, so EHG. EHG is this whole thing. Well, it looks like we have a 30 at E, a 60 at G, and a 90 at H. So that 90 is going to tell us it's a right triangle. EFH, let me change my color for that one. EFH is this triangle here. Now I only see 2 angles marked. I see a 30 and a 30. So don't assume, do the math. You know a triangle adds up to 180. 180 minus 30 and 30 makes 60, so 180 minus 60. You know this angle is 120 degrees. 120 would make it obtuse triangle. So if there's any missing pieces, go ahead and fill those in. Don't just go by looks. Remember that saying, not drawn to scale. Okay, assume everything is not drawn to scale. You can also classify by side length. So equilateral, again, equilateral, all the sides are the same. So 3 congruent sides, which again also means 3 congruent angles. So each angle would be 60 here. Isosceles has 2 congruent sides, and scalene has none. Scalene has none, so they're all different. All right, so that's by side length. So example 2 says find the side lengths of equilateral. So they gave you a little vocab here. There's nothing marked in that picture, but here they tell you all the sides are equal. So you know this side equals this side and this side. So what do? There's 3. Pick 2. So I'll pick the top 2. 3y minus 4 has to equal 2y plus 3. That's why it's equilateral. We'll subtract 2y. So we got y minus 4 equals 3. And we'll add 4y equals 7. Now they did say find the side lengths. So you do have to go plug that back in. 2 times 7 is 14 plus 3 makes it 17. We know they're all the same. So if you plug it in anywhere, it should be 17. 3 times 7 is 21 minus 4, 17. This one will be 17 as well. So there's your actual side lengths. All right, all because of that word equilateral. The next one says classify each triangle by side lengths. All right. So triangle A, B, C, A, B, C. So the thing that sticks out to me are these 2 little tick marks here. Notice this side's 15, that means this side's 15. So this side's 15, this side's 15, and this side's 15. We're going to call that equilateral. All the sides are the same. A, B, D. All right, so I'm going to change my colors. A, B, D. A, B, D is the whole thing. So it looks like we're talking about 15 is this side, 18 is this side, and then B to D is 15 plus 5 is actually 20. So we have a 15, an 18, and a 20. Those are all different, so we're going to call this scalene. All right, so that's by side lengths, So you can classify by angles, or you can classify by side lengths. So this one says find the side lengths of the triangle. So we're looking in this picture, right? And the one thing that stands out to me is those little tick marks. Oops. No, go back. There we go. So those little tick marks. That means these sides are equal. So we would actually call this an isosceles triangle. So we know those sides are equal. We're going to set those sides equal. So 4x minus 1.3 has to equal x plus 3.2. All right, so let's start with the x's. We're going to subtract x from both sides. So we got 3x minus 1.3 equals 3.2. We're going to add 1.3 to both sides. So we got 3x equals 4.5. And then we're going to divide both sides by 3. And we get x equals 1.5. Now, that's not what they asked for. They said find the side lengths. So we've got to actually plug it back in. So 1.5 plus 3.2 gives us this side is 4.7. There's one of them, which means you don't have to plug it in here. We know this side's 4.7. Now you do have to, this one is different, so we do have to plug it in here. So 5 times 1.5 minus 0.2. So 5 times 1.5 gets me 7.5, minus 0.2 gets me 7.3. And those would actually be our 3 answers when they ask you to find the side lengths. If they asked us to classify, we would call this isosceles. All right, there's your homework. Show all of your work. Don't tell me you did this in your head. I want to see all that work. And then upload it to Focus when you're done. Bye, guys.